Hi, and welcome back. In this lesson, we're going to discuss data that should fall within a range. Let's first start off with some motivation. Imagine we have a dataset of movies with their respective average rating from a streaming service. The rating can be any integer between 1 and 5. After creating a histogram with matplotlib, we see that there are a few movies with an average rating of 6, which is well above the allowable range. This is most likely an error in data collection or parsing, where a variable is well beyond its range, and treating it is essential to have accurate analysis. Here's another example, where we see subscription dates in the future for a service. Inherently, this doesn't make any sense, as we cannot sign up for a service in the future. But these errors exist either due to technical or human error. We use the datetime packages .date.today function to get today's date, and we filter the dataset by any subscription date higher than today's date. We need to pay attention to the range of our data. There's a variety of options to deal with out-of-range data. The simplest option is to drop it. However, depending on the size of your out-of-range data, you could be losing out on essential information. As a rule of thumb, only drop data when a small proportion of your dataset is affected by out-of-range values. However, you really need to understand your dataset before deciding to drop values. Another option would be setting custom minimums or maximums to your columns. We could also set the data to be missing and impute it, but we'll take a look at how to deal with missing data in Chapter 3. We could also, dependent on the business assumption behind our data, assign a custom value for any values of our data that go beyond a certain range. Let's take a look at the movies example mentioned earlier. We first isolate the movies with ratings higher than 5. Now, if these values affect a small set of our data, we can drop them. We can drop them in two ways. We can either create a new filtered movies data frame, where we only keep values of average rating lower than or equal to 5, or drop the values by using the drop method. The drop method takes in as argument the row indices of movies for which the average rating is higher than 5. We set the in-place argument to true, so that values are dropped in place and we don't have to create a new column. We can make sure that this is set in place by using an assert statement that checks if the maximum average rating is lower than or equal to 5. Depending on the assumptions behind our data, we can also change the out-of-range values to a hard limit. For example, here we're setting any value of the average rating column to 5 if it goes beyond it. We can do this by using the .lock method, which returns all cells that fit a custom row and the column index. It takes as first argument the row index, or here all instances of average rating above 5, and as second argument the column index, which is here the average rating column. Again, we can make sure that this change was done using an assert statement. Let's take another look at the date range example mentioned earlier, where we had subscriptions happening in the future. We first look at the data types of the column with the .dtypes attribute. We can confirm that the subscriptions date column is an object and not a date or datetime object. To compare a pandas object to a date, the first step is to convert it to another date. We do so by first converting it into a pandas datetime object with the to_datetime function from pandas, which takes in as argument the column we want to convert. We then need to convert the datetime object into a date. This conversion is done by appending dt.date to the code. Could we have converted from an object directly to a date without the pandas datetime conversion in the middle? Yes, but we'd have to provide information about the date's format as a string. So it's just as easy to do it this way. Now that the column is a date, we can treat it in a variety of ways. We first create a today_date variable using the datetime function date.today, which allows us to store today's date. We can then either drop the rows with exceeding dates similar to how we did in the average rating example, or replace exceeding values with today's date. In both cases, we can use the assert statement to verify our treatment went well by comparing the maximum value in the subscription date column. However, make sure to chain it with the .date method to return a date instead of a timestamp. Now that you know all about ranges, let's practice.